or I guess for number 6 too, they only have one angle for each triangle. How would you?
Would that be yes, because they're equal?
Well, like on 3, they only marked one angle, but what do you know about vertical angles?
They're
Congruent. So that would make 2 angles.
oh, well, she did number 6.
6. The top angle would be the same for both triangles.
Okay. How would you know if it's similar or not?
If 2 triangles have 2 angles congruent, then they're similar.
Thank you.
Pose it to the camera.
Thank you.
Because they share the top one. Thank you. No, it's alright.
Thank you.
You know what'd be great? If we could just have candles in here that smell like.
I don't like candles. They burn down houses.
Did you see paper
Yeah.
lanterns?
I did. When did
It's
that happen?
Like, it's like toast. I thought it was just it was a huge fire apparently, because like you could see like black everywhere.
What?
Do you know
there's
when
this
that
restaurant-
happened?
It
I didn't
happened
hear about
during like whenever we had like the Tuesday dog. And
Yeah,
when
I
I
saw
read
that. I
the
was like,
newspaper,
hey.
I was like,
This
oh
place
my
burned
gosh,
down.
this place like is charred.
Was it that Chinese place?
Yeah.
It's always the
Yeah.
Chinese restaurant.
I don't understand.
They're using like flammable ingredients in their food.
Well, it was kind of
fireworks and
ironic
food.
because it's called paper.
Yeah.
You know, paper lanterns
Yeah,
are very safe.
They really aren't though.
Alright, go ahead and do your homework.
Anyway, I'm saying we should candles that smell like coffee. Because
The smell of coffee wakes us up.
that's what I need to smell like.
Oh, I'm feeling better. This is so awesome. Because I took like 4 different
It was so fucking good.
I took so much medicine. When you can like jacked up on medicine.
You can't take too much medicine, it makes me sick.
That emergency stuff.
Like, if I have a cold and I take medicine, I feel like throwing up.
My mom was like, just chug it, and I was like, no. I like took like,
What's that, airborne?
oh,
Yeah.
Very good. They do have an apple cider one though that you can like, that I microwave.
I think Motrin tastes good.
Microwave.
That orange Motrin.
Ew.
Well, you're not, like liquid?
Motrin is for like little kids.
Like the little kids Motrin.
So of
That's
course
like not
Skylar would be
strong
taking
enough.
My mom doesn't buy it anymore, but I just remember it tasted really good.
What is
I
sitting
love
in the
the
snow
flavor
over there? Is that like a
Maybe
microwave?
like medicine?
It's like a
Not
box.
It's a box though.
Yeah. Then he wants more.
There's-
More. I'm like, no.
Do you, okay, so like there's a
Dude, you
some
took my
gummies
chair.
and they're so good. They're supposed to be like full of vitamins and stuff. And they have like they're
Those
gummy and
are
they're like
so
They
bad.
make
I know.
those. They make those for adults. Though.
I know. They like advertise that gummies for adults.
We're
What?
making for pizza, and he kept saying, I want pizza. And I was like, I know you want pizza. Oven.
So I was working last night and I had, okay, the one student I had was like super hyper and she kept trying to turn off the light. I was like, sit down!
Where do you work?
I teach guitar lessons and
Oh, okay.
a lot of them are like 8 years old and it's really hard to have a kid like be really hyper and try to focus on something. And she was all like getting out of her seat and trying to turn off the light and like, oh my god. Focus, just focus.
Where do you do that?
Concert music, it's in Georgetown.
Okay.
Yeah, it was crazy. I was about to like explode.
Of course.
All right.
Mr. Mac.
How did you guys do on this?
Okay.
What?
It's
Yes.
okay.
Did
I
you
think
guys,
if I got them all right.
did you do it together?
Well,
Well, I have answers to all but the very last one. I didn't do that one. 4A was 6.2 meters per second, 35 degrees. B was 13.9 or 14 seconds.
Uh-oh.
C was 50.1 meters.
I didn't get any of those.
wait. Okay, wait. What was 4? Like A?
A was 6.2 meters per second, 35 degrees.
Okay, 35. Yeah, so B's, I'm not sure which side I was supposed to be taking to like say the 71 divide because I thought it was the R.
71 divided, it's time equals distance divided by the rate or the speed of the boat in that case.
Right?
So it's 5.1.
But isn't the distance 6.2?
6.2 is the speed of the boat in relation to the shore, not in relation to the water. But remember when we were talking, and we're gonna talk just a little bit more about this today, the horizontal component and the vertical component are independent of each other. So they're going from one side of the river to the other side. The time that it takes is only affected by the horizontal speed. Because this is the distance that we're talking about, it's only affected by the horizontal speed, not the speed of the river. So for part B, it's 71 divided by 5.1. Yeah.
Interesting. Okay, so then like C, that would then be the 3.6 part.
Yes. But you have to use your answer for part B, so if you got part B wrong, your part C would be wrong too.
And
Is
knowing how I did everything else.
C, so C would be like
We
the,
did it together too, so that means I got it.
the 3.6 times the 13.9 or 14. So to figure out the downstream, the only speed that matters is the speed of the river, and the time is what you figured out from part B. Did you two in the back do that not with the rest of the group? Okay.
I didn't deal with them for them.
Oh, okay. I thought you were saying that you all work together, and I was like, oh. 5, the resultant velocity, so the velocity of the boat in respect to the shore would be 6.9 meters per second, 43 degrees. The time in that case is going to be the same as the time in part 4 because the distance of the river is the same and the speed of the boat is the same. The only thing that changed was the speed of the river. So the time would also be 13.9 seconds. And the distance would be 65.4 meters. You would-
4.7 times 14.
Yes. Number 6, for a boat heading straight across the river, does the speed at which the river flows affect the time required for the boat to cross the river?
No.
That's correct. No, that's correct.
I was like, wait, what?
Yes. It would be no, because the speed of the river does not affect it, like we just said with that. Alright, 7, the first half of 7, the magnitude is 5.4 meters per second and the direction is 306 degrees. The time is 40 seconds and the distance downstream is 175 meters.
What did you say the direction was?
306.
I got 324.
But you have to add it to 360, right?
If you have east and south, whatever angle you got here, you subtract it from 360.
It'd be 4.4 over 3.2, right?
Yes.
But would you be adding the 53 degrees to 270?
No, you'd be subtracting it from 360.
Okay.
Is that what you did?
I added it to 270.
Adding it to 270 would mean it would be this angle here.
Right. Okay.
And I don't have answers for the last part, so I didn't do that one. What'd you guys get for the magnitude?
449.3.
4.93? What did you get for the direction?
238. 1.2.
238. And the time to cross the river?
36.
36 seconds.
Mm-hmm.
And the distance downstream?
155 meters.
Yes? You guys did something? Okay. Good. We're actually to the very last part of the vectors. We still need to talk about projectiles, but especially with all the days we cut off, and we were doing this even before break, I want to do a quiz just on vectors before we move on. So plan on that on Wednesday. We'll review until then.
A quiz?
Yes. The last section is really just reiterating, we're not going to take any notes, it's just reiterating what we talked about at the very end of your last notes, the independence of the perpendicular components. So I just want to go over a couple examples that they give you, and you could read about this also if you wanted to, but one example that they give is, sometimes I can get these pictures bigger, but anyway. One example that they give is the dog on a leash. So the leash would actually be the diagonal part, right? If you're holding the dog's leash, it would look like the diagonal, but it would have those two components. It would have a vertical component and a horizontal component. If you just change the horizontal component, so if you're just pulling back horizontally, your dog is not going to vertically go into the air. The only thing that would change would be the horizontal part. So that's one illustration of how it would not affect the other. These four vectors all have the same vertical component, but they have different horizontal components if you look at them. And if you look at just the distance, just the vertical distance, they're all the same. So if we're talking, if it's like a plane or a boat or something, they would all go the same distance vertically. It would just be a matter of how far they would shift to the horizontal. So just again to show that it's not affected. The resultant vector will of course be different, right? For each of those, the resultant is different, the degrees are different, but it's just not affecting how far they're traveling in the vertical direction. Okay, so that's, that whole section is just about that. This was pretty neat. You can see that on this simulator. So if the boat speed is 3 and the river speed is 2, they would cross in 10 seconds, and they would be 20 meters downstream. If the boat speed stays the same, but the river speed increases, say 5 seconds, 5 meters per second, then it should still cross in the same amount of time. It still crosses in 10 seconds, but it's just gone a lot farther downstream. Right? Okay. So that's what we were talking about before. So let's just go through these multiple choice to make sure that we're all clear on that. What is meant by the phrase perpendicular components of motion are independent of each other? Very interesting.
D?
Yes, it would be D.
Although I think A, B, and C are very
A change in horizontal vector will not directly affect the vertical motion. A boat begins at A and heads east across the river with a speed of 4 meters per second. The river flows north at 2 meters per second. The boat lands at C. Select all that would be true if the river was moving at 3 meters per second.
You would have to. Oh, it's not asking.
C is correct. There would be another one that would also be correct.
A.
Okay.
Oh wait, no.
B. It would not be A. Remember, it always will take the same amount of time to go across. Okay, because the boat's speed has not changed, it's the river speed that has changed. So if the river is going faster, then it's going to be reaching the opposite shore north of where it was before. Because the river's going faster, so it will be going farther up the river. That's what that's saying. A boat begins at A and heads east across the river with a speed of 4 meters per second. The river flows north at 2 meters per second. The boat lands at C. Select all that would be true if the river was moving at 1 meter per second. A. Good. The speed of the boat with respect to the shore would be less, because in the first example the river is helping to carry the boat faster than it would be if it was only 1 meter per second. Right? Okay? A boat begins at A and heads east across the river with a speed of 4 meters per second. The river flows north at 2 meters per second. The boat lands at C. Select all that would be true if the boat was moving at 3 meters per second.
Is that C?
It's the boat that's changing here, not the river. The speed of the boat is decreasing because the speed of the boat was 4 meters per second and now it's 3 meters per second. So the speed of the boat would be less. With respect to the shore, it would be less. It would reach the opposite shore north of C.
Because it's affecting the boat, right?
Because, yes, because the boat is going slower and it's going to take more time to cross the river, then it will also be traveling farther north of where it was before because it's taking longer for it to go across. If you remember that one problem on your assignment from yesterday, when we were comparing the speeds and then how far it made it across the river, the faster the boat is going, the less time it has to drift, the less time that the river has to affect the boat. Does that make sense? Alright, last one. The boat begins at A and heads east across the river with a speed of 4 meters per second. The river flows north at 2 meters per second. The boat lands at C. Select all that would be true if the river were wider. Well, yes, that should be relatively obvious. It would take longer to cross. Good.
B.
Okay.
Let's just mark C.
It would be A and B. B because, again, that's similar to the effect of the boat. Since it takes the boat longer to go across the river, the river will have a longer time to affect it. The speed would not be any greater because nothing's changing with the speed, only the width of the river is changing. Okay, good. Then we're going to go back to some of the riverboat problems. If you want to get a whiteboard, you can get your whiteboard.
Dirty.
Oh, I got mine really dirty.
I'm not going to clean them. It's some kind of a special.
Just make some kids do. But not us.
But not you.
Not us.
Okay. Lucy's new fishing boat moves at 3.2 meters per second relative to the water. How fast does it move relative to the shore when heading downstream with the current in a river that flows at 1.2 meters per second? This would not be a triangle.
It disappeared.
The internet.
I know that.
I'm still processing.
So basically it's going to be simple addition. So it's moving 3.2 meters per second on the water and it's going downstream. So with the current is going 1.2 meters per second.
So it's like 4.4.
Yes, so it'll be 4.4. Lucy's new fishing boat moves at 3.2 meters per second relative to the water. How fast does it move relative to the shore when heading upstream or against the current in a river that flows at 1.2 meters per second?
B.
Yeah. What?
B.
B. Good. Because in this case it's heading upstream, so the current will be slowing it down. Eddie's motorized toy boat moves at 2 meters per second relative to the water. What is the maximum speed with which it will move relative to the shore when in a river that flows at 3 meters per second?
A.
Is it going downstream again, or is it going like across the river? Is this a triangle?
Let's assume that it's the same as the previous two questions. And that it's saying the maximum speed, so it's not telling you the direction that it's going, but it's,
I choose
F.
Or all of them and see which one's right.
okay, because it doesn't tell you which direction that he's going, but obviously if he's going with the river, he'll be going faster than if he's going against the river, so you would add them, yes. Okay, the same question, but what would be his minimum speed?
1.
Good. Alright, the boat starts at A and heads straight across the river with a speed of 0.5 meters per second. B is 10 away from A, and the river flows at 0.25 meters per second. Determine the time to cross the river. How would you calculate that?
Distance over boat speed.
Distance,
Is it width of the river?
time equals distance divided by boat speed, yes. And it's 10. 10 is good.
Is it 40? Because would you be doing 10 divided by the river flow?
No, 10 divided by the
Oh, okay,
boat.
that's what it says. Yeah, so it'd be 20.
So C.
Good.
Not in French class.
I am French.
A boat starts at A and heads straight across the river with a speed of 0.5 meters per second. B is 10 away from A. The river flows at 0.25 meters per second. The boat lands at C. How far is C from B? So what are they asking you there?
The distance from B to C.
Right, which in previous questions has been said,
Is it
the
3.2?
distance downstream.
So find A to C, basically.
So find
So
the
you have to do the
resultant, so do the
triangle.
Pythagoras.
You don't, they're not asking you from A to C, that would be the resultant. They're asking you how far downstream.
And be this.
So just
distance first.
You have to find the time first.
Yes.
can we use the time from the last problem? Or
Yes, because
So
it's the
20.
same.
It's still 10.
20 times 0.25?
A.
Very good. Okay? Everybody with us?
Yeah.
Alright. Now we're gonna find all three parts. So a motorboat is traveling 3.8